The idea with this workshop was to continue some of the work we've been doing in the term in the Architectural Technology and Construction Management course, and that's to try and align the digital side of the program with the first with hand drawing, and then for later on with prototyping and model making.
We've kind of limited the participants to be from Byg and Tech. They've been given a fairly simple task, which is a construction task, to make a pavilion that can be of use to the Refshaleøen project in the future, the mega space out there, or potential interior pavilion that can be used in Kia and Guldbergsgade. And with fairly free hands, they're then making use of CNC and laser cutting just to test run what we could do in a future perspective on Refshaleøen.
The Refshaleøen project is, as we see it, and it's a developing idea, is that we will possibly in the future get an opportunity to build one-to-one models of prototype buildings, structures that we can test, and that the students can test, and we will actually have some opportunity to have hands-on experience with construction. In terms of what the project we're doing now, we see this as a test bed for this idea of so-called maker culture.
And we kind of surveyed the whole maker culture. We were in Harvard University, we were in MIT University, and we were in Tech Shop, and we visited various companies that are all making professional use or academic use of maker culture, both in terms of study but also in terms of profitable production. If Kia then develops a kind of a maker culture in its didactics that's even stronger than what it is now, then we also distinguishing us from the universities that are in their nature much more theoretical in their didactics.
Everything we are trying to do should be represented by some kind of a deliverable, whether it's a model or a design or something that is produced. So there's always, in some way, a physical product, or at least the next stage to a physical product on the way. And that's the big difference, I suppose.
One of the main benefits in using the techniques for product development that we're using in this workshop is digital manufacturing. So digital manufacturing, instead of a person controlling your machines, you have a computer controlling your machines. So that gives you certain advantages, and one of them is scalability. So this project we have here is a project we did for the Roskilde Festival. We have different iterations of these triangle shapes. There's one smaller here, there's one where we try to have some ellipse shape, and then you see the final model that we chose, which is these triangles with rounded corners. So this is done on a laser cutter, which is one of the machines we use within digital manufacturing. And it's a very fast way to have what I call physical sketches. So you have something you can hold, you can stand around it with your project team, you can look at it, you can look inside it. It gives you a certain amount of tangibility that you can't have in a 3D CAD model on a computer. So what we did is, when we had the design finalized, it was very easy for us to take our digital file and simply scale it up. So this is a direct output of this scale model. And in normal manufacturing, I would need to cut this manually with a knife, a cutter, or maybe a small jigsaw or something. And then if I wanted to cut this, I would again need to manually do all this, and that's, of course, is a lot of work. But here I can simply tell one machine to cut this shape, take my drawing, multiply it by 6 or 5 or what my scale is, put that into another machine, and same machine follows the same line, only in a much bigger scale, which allows us to do product development in a much faster pace, because we can do many design iterations. And then, of course, when you have the final product, you simply press Ctrl+C, Ctrl+V, because it's digital, and you just copy-paste, and you make as many as you want.